Okay, moving on to example 2. It says to solve this equation by factoring, which is the technique we learned back in chapter 2-3, or also they want you to do it with quadratic formula. That's the one we're just learning right now. And they want us to come up with which way we like better and why. Now, you're probably going to find out you like the quadratic formula better, maybe, maybe not. Sometimes the numbers in the quadratic formula get large. People don't like it for that reason, but whatever. All right, if I'm going to do this by factoring, I first look at the structure. First off, just like everything else, this is what I want. Everything equals 0. That's what I want every single time. The quadratic function in descending order, x squared first, x second, constant last equals 0. Whether I'm doing quadratic formula, completing the square, or factoring, whatever, I want that structure. If I'm going to factor, since there is a number in front of x squared that's not 1, I need to multiply these two numbers here together, right? So I want factors of negative 120. And I want the sum of those factors to be whatever that number is, negative 7. Okay. And we can compile this list: 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 7 doesn't go, 8 times 15, and so on and so forth, right? Okay, we can just go down the list and compile every possible way to make 120. The correct pair is going to be negative 15 and positive 8. These two numbers multiply to make the negative 120. They add to make the negative 7. So negative 15 and positive 8 are the correct breakdown of negative 7 and negative 120. And what we do when we have a quadratic trinomial with a coefficient in front of x squared that's not 1, in other words, it's not just x squared, it's 6x squared or 5x squared or 10x squared. When there's a number in front of x squared that's not 1, we're going to modify this term into these two coefficients for the x. So it's going to look like this. 6x squared minus 15x plus 8x minus 20 equals 0. That is the technique of factoring that we've learned for a coefficient not equal to 1 in front of x squared. Once we've done that, now we're going to factor by grouping. Group 1 is right here, and group 2 is right here. Now, something I did without much fanfare, but it's important. I had a choice of what order to put these two things in. I could put negative 15x first, positive 8x second, or positive 8x first, negative 15x second. I'm going to group the first two, group the last two. That equal sign should not be on that side. If I put the positive term in the 1, 2, 3, third spot, I get a plus in between the parentheses, makes the problem easier. So when you have an option, put the plus in the third slot. Makes it easier. Group 1, I'm looking for common factors. Can we all see that x obviously belongs to both objects? Can we both see 3 divides both numbers?
Yep.
So 3x is a common factor. We divide by 3x to get whatever's left over. So 6x squared divided by 3x is 2x. Negative 15x divided by 3x is negative 5. Okay, looking at the second group. We all see that 4 divides both numbers evenly. Anything bigger than 4?
Oh, yeah. No.
No, nothing else, right? So 4 is the biggest number we can take out.
I thought
Take a
20
4 out.
too.
8x divided by 4 is 2x. Minus 20 divided by 4 is negative 5.
Why'd you put an X in front of 4?
Why didn't I?
Yeah.
See how this has an x, this has an x?
Oh,
So
yeah.
x is common. This has an x that doesn't have an x, so x is not common. You're only allowed to pull out what's common, so it has to be in both pieces. All right? So when factor by grouping works, what you should be looking at is this binomial expression should be exactly the same as this binomial expression. If it is, that's one of the factors. So one of my factors is going to be 2x minus 5. The other thing is if those are the same thing, then this and this make up the second factor. So the second factor is going to be parentheses 3x plus 4. So again, that's how you go from here to here. Whatever's the same is one factor. Whatever was pulled out is the other factor, and those factors being multiplied together. And the whole purpose of factoring is to change from a sum and difference structure into a multiplication structure, because when we multiply 0, we get 0. So either 2x minus 5 must equal 0, or 3x plus 4 must equal 0. One or the other. Just a little algebra, excuse me. Just do a little algebra there and you get x equals 5 halves and negative 4 thirds. Dry throat, not good. All right, so that's the factoring technique. It gets us two answers, 5 halves and negative 4 thirds. Okay. If we had done the same problem using the quadratic formula, I'll use this space over here for the quadratic formula. If we start off with the structure we're looking for, 6x squared minus 7x minus 20 equals 0. Again, if it's not written like that in your book, your first step should be to write it like that on your paper. Move whatever needs to move, change the signs of things that didn't move. All right? Once you get that order, you can identify A, B, and C. A is equal to positive 6, B is equal to negative 7, and C is equal to negative 20. I want to identify the value of negative B, 2a, and b squared minus 4ac, the three pieces of the quadratic formula. So negative b is going to equal positive 7. 2 times a is equal to 12. Those two are rather easy. I do them really quickly. Okay? Change a sign, double a number. Two really easy skills. All right, the b squared minus 4ac, a little bit more challenging. Take a little more time on that. B squared means square b. B is 7. 7 squared is 49. Again, b squared is always positive, never ever negative. Square it in your head and write a positive number. Then we have minus 4 times a times c. And a is positive 6, c is negative 20. Make sure you get all the signs in those boxes so you have the correct product you're looking at. Here's the product I'm looking at. So 49 is just 49. Minus minus makes plus. 4 times 6 is 24, times 20 is 480. 480 plus 49 is 529. So again, evaluate negative b, change the sign. Evaluate 2a, double a. B squared minus 4ac, evaluate what you're looking at. 4 times 6, 24, times 20 is 480. 2 minuses make it plus. 7 squared is 49. 49 and 40 make 529. Just arithmetic. Carry out the arithmetic carefully. Now that we got all three of those numbers, the quadratic formula says that x should equal our structure, and in that structure, opposite of b goes here, b squared minus 4ac goes here, 2a goes on the bottom. And just applying the quadratic formula, the exact same form we just used in example 1, putting the three numbers we just found where they belong in that structure. Square root of 529 is what?
23 it is.
If you have not yet done so, if you memorize every perfect square from 1 squared through 25 squared, so you're familiar with those numbers, it'll save you time and energy. And when you get to the ACT tests like that are standardized timed tests, you're not sitting there racking your brain for 15 seconds doing something you can do in a half a second because you memorized it. So 1 squared through 25 squared is the most frequently used numbers for perfect squares in math books and on math tests. So you just take 5 minutes a day for a week, little flashcards, just memorize those facts. You already know most of them. There's a few you don't know. Learn those and get them known. All right. So when I can evaluate the square root to an exact number like 23, it's not like 2 times the square root of 31 like the last problem. It's actually 23. It's just a whole number. The radical's gone. Then what this plus minus means, that I'm going to get a sum over 12, I'm going to get a difference over 12. The sum is 7 plus 23, which is positive 30. The difference is 7 minus 23, which is negative 16. All right? So when you do get an exact perfect square like that, these square root evaluates to an exact integer like that, I'm expecting you to get simplified answers like this. And then finally, notice 30 over 12 reduces by 6 down to 5 over 2. Negative 16, 12 reduces by 4 down to negative 4/3. The exact same answers. Both techniques work. Both techniques get you the right answer all the way down to the most simplified form. Okay. This technique requires you to learn how to factor really well. Once you get it factored, though, it's pretty simple algebra to get the answers. This one requires you to learn a property, learn a rule, and you have to be able to evaluate all that stuff carefully and correctly. So each has their pluses and minuses. For me, I'm going to go with quadratic formula. Every single problem is this much work, no matter how ugly they get. Every problem, that much work. This sometimes quicker, sometimes slower. This is always the same, so it's a known quantity. I prefer that better. For the sake of tomorrow's quiz, use the factoring technique. Do not use quadratic formula on tomorrow's quiz.